Hi guys, I'm back with another video. We're on to objective 3 in chapter 10, factorial design. So I'm going to go ahead and share my screen and get straight to objective 3. All right, well, apparently this stupid thing went right back to the beginning. So I have to get down to objective 3. Whoop, too far. Yeah, I haven't quite figured this out. Okay. So here's objective 3, and come on now, mother. All right. Contrast factorial randomly assigned designs, factorial repeated measures designs, and mixed factorial designs. So let's take a look at that. What is the difference between them? Well, you've heard the words randomly assigned before. And so the factorial randomly assigned design, of course, is going to be people who are randomly assigned to groups. And there we have everybody being in a different group, each person only experiencing one condition. So if there's 6 conditions, one person only ever gets in one. Factorial repeated measures design is just as we've talked about repeated measures design before, where each person gets in every single condition. And then the mixed factorial design is where we have one randomly assigned factor and one repeated measures factor. So we'll take a look at those independently. Let's take a look at a factorial randomly assigned design. It's when the researcher is going to manipulate 2 independent variables in one study. So just like we've seen before in the last example from the last video, we can manipulate both hair color and outfit in job interviews to see how that influences the interviewer's take on the candidate. And so 2 independent variables in one study. And what happens here and what makes it randomly assigned is that each participant is going to serve for one level of each independent variable. And so what's going to happen is each participant is only going to be in one condition of the independent variable. And I'll give you an example of that now. This is a study I did several years back with a student by the name of Carlos Roberts. And we looked at physician gender and physician communicative style. And those are 2 different variables here. So we had doctors, and we had a male doctor and a female doctor. These were actually actors who were playing doctors, and so we matched them on a whole lot of things, their height, their weight, and stuff like that. So we had a male doctor and a female doctor, and then we videotaped them doing different things. So for example, the male doctor was videotaped in an affiliative communication style, and that was where he was very friendly and he was making eye contact and very nice, and very cordial, but he was saying actually the same exact things in every video, but either he was saying them in a friendly way or not. And then in the not so friendly way, he was controlling. And so in the controlling video, he was kind of telling the patient to do things, and not quite so non-verbally friendly. You know, he kind of sat back, he didn't make good eye contact with the patient and stuff like that. And then we had the female doctor do the same thing. And the idea was, what strategy works best for doctors? And so what we did is we had the patient then rate these doctors on how satisfied they were with the doctor. So if you were in this study, you would have either gotten a male doctor who was real friendly and affiliative, or you might have gotten the female doctor who was very friendly and affiliative, or you got the male doctor. Oh, I was going to try to show you with my little cursor here. Okay, either that or you got the female doctor who was very controlling, she wasn't very friendly, or you got the female doctor that was affiliative. So you can see that these are completely crossed. Here's the female affiliative, here's the male affiliative, here's the male controlling, and here's the female controlling. Now, what we measured was patient satisfaction scores. So you can see that that's what these numbers indicate here. And so take a look at this and see what you think. Now, in terms of the results or what happened, because we'll talk about that in a minute. But again, the reason why this is a factorial randomly assigned design is because the people that got the male affiliative doctor, they didn't see any other doctors. This is a whole different group of people than this. the people who got the female affiliative doctor, they didn't see any other doctors. We didn't want them to know what the study was about. So we only showed them one doctor. And they were randomly assigned to see one of 4 different videos, okay? So if you examine these results, what you'll see is that the male doctor did slightly better when, better when he was better when he was controlling than when he was affiliative. So male doctor got away with not being quite so nice. Patients were satisfied more than when he was super nice. But with the female doctor, what you found is that when she was super nice, she got rated better than when she was controlling. So a bit of sexism in there. Okay, well, we're going to talk about the kinds of effects that can come from this sort of study. So one is a main effect, and that's the effect of one independent variable. So, for example, the effect of physician gender. And to find that, what we want to do is collapse across levels of communication style. And so I'll kind of show you that in the next slide here. What we've done here is to find the effects of physician gender just by itself. What we've done is collapsed across these two. So we're collapsing across controlling and affiliative. And we add those together and divide by 2 to take a mean. And what we get there is 59. To get the effects of the female gender, what we would do is add 48 and 32, divide by 2, and there we get 40. And what you can see there is that the male doctor is actually liked more than the female doctor, as you can see. But that doesn't really tell the whole story of the results, as you can imagine. So we'll get back to the whole story of the results in a second. If we wanted to get the main effects of affiliative versus controlling, we do the same, except we're going in this direction now. So there you can see that the effect, trying to move my face up, the effect of affiliative is a 51 there. So so they like the affiliative doctor a little bit more. They like the nice doctor a little bit more than the controlling doctor, but that's actually, there's not a big effect there. So you can say, well, communication style doesn't matter, but it does matter is the reality. And why it matters is because it's different for men and women. So let's take a look again at that interaction. So the interaction is the relationship between one independent variable in the scores and how it changes as the level of the other independent variable changes. So, for example, the effective communication style is different for males and female doctors. So remember, the male doctor did all right with that kind of controlling, sort of not so friendly communication style. If it was the same, if the effective communication style was the same for both male and female doctors, where they always did better when it was affiliative, for example, then that would not be an interaction. So let's take a look at the interaction there. If I graph it out, all I've done here is put my dependent variable over here on the vertical axis. I put one of my independent variables here. I put my other independent variable right here in the legend. And what you can see is that for the male, the affiliative was not so good as the controlling. But for the female, the affiliative was better than the controlling. And there, you see where we get that X there in the pattern on the graph, it denotes the interaction. So that's an interaction effect. So you can't say that affiliative is always better, because affiliative is better only for women. And so you can't say that controlling is always better, because controlling is better only for men. And so there we get the interaction between the two variables. Two variables are working together to produce different effects. So in this case, if there were no interaction, if controlling would always be better, this is fictional, of course, than affiliative, but controlling is not always better than affiliative. It's only better for males than for females. So that's what it would look like if there was no interaction. But of course, in these data, there are an interaction. Okay, so what do you do to interpret the results in the case of an interaction? Well, here's what you do. We interpret the main effects very similarly than we would as a single factor design. We do an ANOVA, or a one-way, what we've called a one-way experiment. The ANOVA is going to test for significance of the main effects and the interaction. But if there is a significant interaction, it will take precedence over the main effect. So you won't talk about the main effect as long as there's a significant interaction in your data. You'll just talk about the interaction. So when we talked about the results of this experiment, which we ended up publishing in a journal called Social Science and Medicine, when we talked about the results of this, we only talked about the fact that for women, affiliative was better. For men, controlling was better. We never talked about, men are better in general or affiliative is better in general or anything like that, because we really don't talk about those main effects as long as there's a significant interaction. So if there's a significant interaction, we focus on the interaction. We do not worry about the main effects in that case. Okay, next time we will get with factorial repeated measures design. Thanks for watching.